All right. Hello, everybody. Thank you for coming to my talk about breaking Tizen. A little bit about myself. My name is Amichai Neiderman. I'm a security researcher from Israel. I mostly do vulnerability research. My day job is looking for vulnerabilities in iOS and Android phones. And my hobby is looking for vulnerabilities basically in anything that has Wi-Fi in it, or what people nowadays call IoT. I just call it boxes. I like finding vulnerabilities in different boxes. You get a chance to see a lot of different technologies. So it's fun. I like doing it. Now, before we start talking about what Tizen is, I want to talk about its history. Now, the history of Tizen is a bit too long for a 20-minute talk, as you can see here by this graph. So I made this graph instead, which is a bit simpler. It's not 100% accurate, but you can trust me, it's good enough. Now, for a long time, Samsung wanted to have their own operation system. And they started in 2010 with something called SLP, the Samsung Linux platform. It didn't work very well, and then they started making something called Bada. It didn't catch up, like you guess. I think it only ran on some digital cameras. So in 2013, they merged the code bases from those two operation systems in something called Tizen. Now, Tizen's supposed to be the operation system of everything. And when Samsung say everything, they actually mean everything. It's supposed to run on smartphones, tablets, in-vehicle infotainment, smart TVs, smart cameras, wearable computing, Blu-ray players, printers, smart home appliances, refrigerator, lighting, washing machines, air conditioners, oven, microwaves, and even robotic vacuum cleaners. Now, most of you might not be aware, but there is a great chance that some of you already own a Tizen device, a device running Tizen OS on it. Maybe the most notable one is the Gear S2, which actually started as an Android device, but then Samsung moved it to Tizen in 2014 without actually telling anybody about it. Another really common Tizen device is the Samsung Smart TVs. The new versions are running with Tizen. There are about 21 million Tizen TVs worldwide. And not so recently, Samsung started producing and selling smartphones with Tizen on them. They are all labeled with the letter Z. And they are not part of the Galaxy family. Even though you can see some Galaxy strings in the firmwares, even here in this picture, you can see the Galaxy. And the Tizen look and feel in the mobile world is very much like Android. And it makes sense because Samsung really helped to shape the Android user experience. And I guess they also want to have something that will be similar to what Android user would expect. So you can see the same tile layout as we know from Android. Now, this January, Samsung announced in CES they unveiled their newest product lines. And most of them are running Tizen. They have Tizen washing machines, Tizen refrigerators, vacuum cleaners, and they even talked about Tizen phones. So it looked like Samsung is planning something big for Tizen, maybe even making it their main operation system instead of Android. A lot of people are claiming that in the last few years. Now, over the last decade or so, Samsung has been using Google's Android as its primary operation system. And for a while, the two companies, Google and Samsung, had a lot to gain from this partnership. Because Samsung manufactures quality phones like the S2, the S6, the Note 7, and they control about 60% of the smartphone market worldwide. And Google got accessibility to millions of users worldwide this way. But today, Google have their Android OS. They have their Pixel phones. So they're not that dependent on Samsung anymore to manufacture quality phones. Apple have their iOS and they have their iPhone. Now it comes in red. And it only makes sense that Samsung will want their own operation system that will run on their own hardware, just like the big ones do, like Google and iPhone, where they could do whatever they want, whenever they want, without anybody telling them what to do. Because when Samsung used Android's OS, it came with a lot of stuff that Google want them to do. They want them to put the Google Store in there, the Google search engine, the Android Pay, and they didn't let Samsung do whatever they want on this device. So it makes sense that they want to have their own operation system. Now, let's talk a little bit about Tizen under the hood. Now, Tizen is essentially just Linux. The core is open source. Most of it is open source. There are only small part of the ecosystem that are maintained by Samsung and are closed source. They wrote some parts of the networking and messaging. And just like Android and iOS, they also have a concept of applications. And you could develop applications in two different ways. You could either use the web framework, which is pretty cool. You can just write your app in HTML and JavaScript, or you can write it in native code, in C or C++, which is pretty cool. And in terms of security, they've decided to use SMAC instead of SLinux, probably to separate themselves from Android. But as you'll see as the talk goes on, Tizen is very much like Android in some aspects. The first one I noticed was in Android we have the ADB, the Android Debug Bridge. And in Tizen we have SDB, which stands for, that's right, Smart Debug Bridge. So that's the first thing I noticed. But anyway, now we know everything we need to know about Tizen for this talk. We know that Samsung is gambling a lot on the success of Tizen in the next few years. But when I started looking at Tizen in the first place, they only sold it, at least in the mobile world, in two places, in India and Bangladesh. And it brings me to the question of why I actually started researching Tizen in the first place, if they only sold it in those two places. So I was looking at some Android firmwares, as I often do, because that's what I do. And I noticed those three strings that I'd never seen before. Install WGT, install WGT in APK, and is WGT installed? Now, I've never heard of this WGT file format. And when I searched for it online, somebody mentioned it's the new file format for application to the new Tizen OS. I said, all right, I've never heard of it, and I don't really care about it, and I just moved on. But a few days later, I went and bought myself a new smart TV, and it said on the box that it comes with Tizen OS. So I got interested because I remembered this Tizen from a few days ago, and I started researching online about Tizen, and I came across this website, tizenstore.com, which is an official Samsung site. It's basically just like Google Play or the App Store. And when I got to this site, it's just like browsing to the Google Play Store through your browser on your PC. And you can see here that they translated this site into two languages, English and some kind of Hindu language. And it supported only two countries, India and Bangladesh. A few days later, when I got to this site again, I saw that they added an extra country, Nepal. Now, the interesting part was that they weren't even selling any phones in Nepal. Only about a week or 2 weeks later, they published a rumor that they're gonna start selling Tizen phones in Nepal. So I thought, well, that's pretty cool. This site is a cool way to predict where they're gonna sell next. And in the course of the next few months, they added support to more languages and more countries. They added Sri Lanka, South Africa, Nigeria, Nepal, Kenya, Indonesia, Ghana. And there are even some countries that they are not selling Tizen phones to this day in this list. So it looked like Samsung are laying the groundwork for a greater expansion of Tizen to new markets. And you could see the exact same thing if you look at their firmware. If you unpack their firmware, you can see that they added support in 2014. They had support in only one country, India. They only had Indian MCCs and MNC in their configs files. That means that you could only connect to Indian networks by default. It only supported several Hindu languages and English. And like you expect from any Indian firmware, they had this fantastic cricket app. And apparently, cricket is a big thing in India. I did not know that before that. So they added this. If we look at the firmware from 2015, then we can see first signs of new countries being added. So you can see signs of Bangladesh, Nepal, Sri Lanka, and they also added a Muslim Times Prayer app. And they also added a bunch of new languages for SwiftKey. They added support for let's see, they have Bangladesh, India, Nepal, Sri Lanka, China, Korea, and even Pakistan. So what I've been trying to tell in the past 10 minutes or so is that Samsung is planning something big for Tizen. It's trying to spread around the world. And we should all pay attention to it, especially security researchers like I did. Now, Samsung has been trying over the last few months to lure more and more programmers to develop it for Tizen. And there is something most people don't know, but Samsung liked developers to try their apps on physical phones before they release them to the public. And the way to do it is that they give you this remote test lab. You could connect to this remote test lab. You get this. You get a connection to a physical phone. And you can test everything you want. You just apply for a time slot of between 30 minutes to 2 hours. They ask you nicely to log out from Facebook afterwards, because people could use this phone later on. And gradually over time, they started with only Indian servers and Korean servers, but then they added support in Poland and in the US, probably trying to approach developers in Eastern Europe and North America. And they also aggressively started convincing developers to port their apps to Tizen by giving away about $10K a month to the apps who are in the top 100 apps in the Tizen store. And maybe their biggest move so far was joining the .NET Foundation, not so recently. They're trying to make C# what Java is for Android, and by this way, bringing all those .NET developers into Tizen. But for me, the reason I actually wanted to start researching Tizen is when you go to cvdetails.com, there are currently 0 CVEs for Tizen. And I want to be one of the first to do it. And basically, when we decided to do it, Samsung announced that they invested about $10 million in security solution for Tizen. And I want to see where this money has gone to. So I went ahead and bought 2 Tizen phones. I think those are the only Tizen phones to have ever been in Israel. I ordered them from eBay, from India. If somebody wants to see a Tizen phone later on, you can come and see it. And I bought them. And I started researching them. And before we talk about what I found, which is the heart of this talk, I compiled a list of rules that I think most of Samsung Tizen developers follow in during their production. That's my impression from looking at the code. So let's just start. I call it being a Tizen developer, the untold rules. Well, the first rule is a string should never be longer than 256 bytes. Because there's no reason for a string to be longer than that, right? I'm manning the what attack? If you're not sure you need SSL, don't use it. And I trust everything that claims it came from Samsung. You tell me when to stop reading data. With 1 GB of RAM, malloc could never fail. And no code review is needed, ever. So this is the list I compiled. The first app I looked at was the Tizen store. It's basically just like Google Play. Maybe it's the reason for making Tizen, because Samsung for a long time pursued this dream of having their own application store, and now they can. It's installed on every Tizen device, and it's very highly privileged because it's supposed to install apps, update apps, and do a lot of system maintenance. Now, the way it works, a bit on the technical side, they have a simple server-client protocol between the client installed on the phone and the server located somewhere in the internet. It's a simple textual protocol over HTTP. There are about 100 different messages, and most of them follow rule number 3 of use as less SSL as possible. And the way it works, we can see it in this piece of code. They have a function called ItSecureConnectionNeeded. For every message coming out, they're checking if this message needs to be sent over a secure connection or not. Now, I'm not sure why they did it, but for every message type, they have a list of all the messages that are supposed to be sent on secure connection, and not all of them are being sent on secure connection. An example for one message is this. It's the send image download. And what we can see here, it's just a message being sent to the server asking to download an image from a URL that the server sent it before. And if we look closely, we can see something from way, way back that we don't see anymore. They're taking this string, this image URL that we send it as the server because it was sent in plain HTTP, and they're copying it into a buffer of a fixed length of 512. So this is a really basic heap overflow. We also have this, just an example of bad coding. We have this calloc that's being called and nobody checks its return value. So what we have in this function is using obsolete unsafe function, not checking for array bounds, and some nullity ref. But mostly what we see is that nobody even tried doing a proper code review to this code, if any was done. This code has it all. And here's a really good example. You might be wondering, by the way, why I have this really neat looking functions with the function names and variable names and everything. Somebody in Samsung thought it's going to be a really good idea to compile everything with debug symbols, making my life way easier. So thank you, Samsung. So here we see a function called parse response error. And what it does, sometimes their app server has a problem, and it can decide either to send a list of error codes to the client or sending a custom string. If it sends a custom string, an error string, what it does, it checks to see if the length of the string is longer than 1, and again, copying it to a buffer of a fixed length of 256, leading to a heap overflow. So we have the same thing here. We have using obsolete unsafe function, not checking for array bounds, and checking there is enough data for heap overflow, and then overflowing the heap. I actually exploited this function, this vulnerability. This is the one I chose to exploit because it was fun. And the list of vulnerability just goes on. We have not checking for array bounds, no proper stop conditions, not validating return values, path traversal. And they actually did a pretty good job defending against SQL injection wherever I looked. So good for you, Samsung. You can have this one. And if you play Pokemon Go, then most of those vulnerabilities are like Ratata. They're pretty crappy, and you can find them anywhere. So it's the same thing. Another nice app I was looking at was the Samsung Cloud. Samsung really want to have their own cloud service. And here we can see another great example of good coding practices, like allocating a buffer of 1,000 hex, and then mem setting about 1,001 bytes, doing an off by 1 always. I'm not sure why they did it. You can read data from the socket into this variable, and then allocating as much data as I tell it, and then copying data to this buffer that you just allocated. So you can just allocate 0 bytes and cause another heap overflow. So to just link anybody to decide how they want to attack this function. Now, before we run out of time, I don't think this talk will be complete without browser vulnerability. That's what people like these days. That's what people talk about in a lot of talks, in Pwn to Own. That's what people like. So for the sake of this talk, I, for the first time in my life, opened a browser code. Some of it was open source, I had to reverse engineer, and started looking. And I found a vulnerability. And about 3 hours before my flight, somebody from Samsung contacted me, and we started talking about this vulnerability. And when I tried to send him a link to the vulnerability from their open source site, I saw that one of those developers, Jae-Kook Lee or Jung-Soo Lee, closed the vulnerability. They actually changed the code around it, and now the code with the vulnerability is gone. I don't think they intentionally tried to close it. But I was already talking with this guy from Samsung, and I promised him vulnerability. So on my way to the airport, I was actually sitting in the terminal. I found this vulnerability, because I promised them something. I think it's exploitable. I asked them to check it. They haven't returned any of my email ever since. But I sent them this vulnerability. Yeah, I think you can exploit it. I have a few ideas to do it. I've done stuff like that. Now, let's do a quick summary. I found around 40 different bugs. Most of them look exploitable. It felt like 2005 in terms of the vulnerabilities I found out of mem copies, SCR copies, everything that you'll open a book about vulnerability research, and it might be the first example that you'll see for a heap overflow or a stack overflow, or just for a buffer overflow. I exploited one function, the one I showed you before. I had one mini heart attack when I tried the browser vulnerability on my TV, and my TV crashed. And I was really afraid that it won't come back, but a few minutes later it got back. So I was pretty happy about that. And maybe the most important thing I want you to take from this talk is that there is a great chance that we're going to see the Galaxy S9 from Samsung coming out with Tizen OS on it. And right now, Tizen isn't mature enough, isn't ready enough to be sent to the public like this. If those are the vulnerabilities I found in a few hours of research, then somebody that's really going to dedicate himself to be a Tizen researcher will find way more vulnerabilities. And well, you can't have a phone like the Galaxy S9 shipped to the public like that. Now, currently, Tizen is aimed to developing countries. If there's somebody from Samsung here, then I want to tell you that I think they deserve security too, even if they come from India and all those developing countries. I don't think you can just send stuff like that to them because they don't matter to you. And I invite you all, my fellow security researcher, to join Tizen ecosystem. It might be a new business opportunity for you. There are millions of TVs, smartphones, smartwatches, refrigerators. Everybody wants to hack a refrigerator, right? Somebody just found a path traversal in a dishwasher. Exciting times to be living in. So I encourage you all to join me into researching Tizen. Thank you very much.